Okay, so tēnā koutou, and thank you for joining us today. And on behalf of Te Toputanga o Te Whare Koru ki Aotearoa, or Passivhaus Aotearoa, welcome to this next session of our 2025 webinar series. So I see lots of familiar names in the call today, but briefly for those of you who are unfamiliar with PHINZ, we are a charitable trust and affiliate of the International Passivhaus Association. And our main role is to help industry to transition to a future where our buildings support the health and well-being of people while minimizing the burden of those buildings on the environment and eliminate fuel poverty for our vulnerable communities. As I'm sure you all know, Passive House is a fabric-first approach to achieving this, but the systems in passive houses also play a critical role, which brings us to today's topic of ventilation systems. So ventilation systems, high-performance ventilation systems, improve the energy efficiency of buildings by between 2 and 3 times via the heat recovery in them, but they also improve the durability of the building fabric by removing moisture, and they improve indoor air quality, which in turn improves the health of occupants. So just briefly, some housekeeping. If you would like to submit a question for our speakers, then you'll find the chat by going to the bottom toolbar, click on More, and then select Chat, or you can use the shortcut Alt and H on your keyboard. And if you see a question that you like, you can give it a thumbs up. And at the end of the session, I will read the questions to our speakers, and they will be able to answer them for you. Just a reminder that if you are claiming points for this webinar, you get 2 PHI CPD points and 15 NZRAB points. 80 NZ is 1.5 points, and you can also claim this time for your LBP points. So firstly, a huge thank you to our sponsor, Fantech. So Fantech were among the first in the high-performance ventilation space in New Zealand, with their products installed in most of the first passive houses in New Zealand, and they've been a consistent supporter of Te Whare Koru. So just briefly to introduce you to myself, for people who don't know me, my name is Jessica Winter. I am a board member of Te Whare Koru, and I am a certified passive house designer and certifier. So many thanks to our speakers. They've given up a significant amount of time to put this together for us. So I will just introduce you to them. So we have Tim and Cam with us today. Tim Ross is well known in the passive house community for his groundbreaking work on certified passive house buildings for vulnerable communities, including New Zealand's first multi-unit residential project. Tim is a registered architect and principal of Archetype, which is an award-winning architectural practice specialising in the design of passive house buildings. As in the title of this webinar, Archetype are experts in integrating ventilation systems into projects, right from the early concept stage through to commissioning the systems on site. And Cam Kilgour is National MVHR Manager for Fantech. Fantech have, as I said, have had a significant presence in the high-performance space since the very early days. And Cam himself is not only an MVHR specialist, but also has wide experience of passive house products and how the other passive house products and how they work together as a system. Oops. So I'm excited to learn from these two, and I'm sure you are too. So now I will invite Tim to kick off with his presentation, and Tim and Cam will be presenting this for you today together. Kia ora, Tim and Cam.
Right. Hi, everyone. Thanks for joining us. I should be able to share my screen. Is that all visible?
Yep, that's live.
Yeah, okay. Yeah, well, thanks everyone for joining us. This is going to be a bit of a whirlwind tour. We've got 45 minutes to run through a whole range of different aspects of heat recovery ventilation from concept to commissioning. So we're going to move reasonably quickly. We're going to assume a reasonable level of knowledge from most of the people on the call, but by all means, feel free to ask any questions at the end. Try to stick to time. So yeah, we've got 45 minutes for the presentation, and it's basically going to be Cam and I will switch back and forth talking through the presentation. So is it going to behave? Oh yeah, okay. So why MVHR? And first of all, what does MVHR mean? It's mechanical ventilation with heat recovery. So that's the abbreviation that's commonly used for heat recovery ventilation, both here and overseas. I'm hugely passionate about mechanical ventilation in buildings. I live with it in our own home. And I've just seen the impact that it has on air quality and keeping things dry and keeping things warm, and the impact that it's had on power bills and also for all our clients that we've specified these systems for. So I very much see it as like installing plumbing, electrical and ventilation. It feels as though you're making a dumb building if you haven't got airflow coordinated into the overall design. So the positives of MVHR is fresh air without losing or gaining heat would be the first biggest one. So because these systems have a heat recovery core, you get fresh air constantly moving through the house, no matter whether it's windy outside or still. But you don't, every time you lose the window, with typical opening windows, you lose the heat that you've put into the air. With the heat recovery system, you dump the stale air, but you hold on to the heat. So that means that you do it away with bathroom fans, and range hoods ducting directly outside usually, and you hold on to that heat, but really get that proper good ventilation. And it also works in hot climates as well, so you can actually hold on to the cooler temperatures inside and keep the heat out as well. One of the huge benefits that I think is probably underestimated or not well understood is that these systems act like pumps that are constantly pumping moisture out of the house. So if you've got a busy house where there's cooking and showering and people breathing and pets and things like that, you accumulate moisture inside the house unless you open the windows. And that doesn't happen so much in the winter. So with these systems, you've got a constant pump of that's moving moisture out of the house. They've got condensate drains in them. Those drains frequently are quite busy draining moisture out of the house. So particularly in weather where it's wet, people are coming inside and hanging out their coats and there's wet shoes and things like that. Your house is constantly being kept dry to that sort of 50% relative humidity point. And it means that you do get a lot less condensation on things like windows, and less likelihood of mold forming. They keep out pollutants and pests. This is a big one for people with allergies. These systems have filtration built into them, so they keep the pollen out, they keep the exhaust fumes out, they keep the pests out. Particularly in winter when you've got the windows closed. Summer, obviously you've got windows open more frequently. And they also keep the noise out. So again, this is really important with dense housing. You can have your windows shut for more time. If it's noisy outside, you want a good night's sleep. You don't have to sleep with your windows open. You can close them and benefit from a quieter night's sleep. And they are absolutely essential for draft-proof buildings. If you're going to make a building which aims to be airtight or draft-proof, you must put a heat recovery ventilation in. Certainly some sort of ventilation system in, but you'd kind of be crazy not to put one with heat recovery in. And one of my pet things is they're brilliant for drying cupboards. You can also, I'll talk a little bit about it later, but you can install drying cupboards in your clothes, so you can do without having a dryer and the associated power bill from that. So there's lots of benefits of these systems. Just very briefly, this is the core of a heat recovery system. Suffice to say is it recovers heat, but there is also, it's important to note that there's also a bypass on these units. So there's a brain, there's a computer motherboard connected to this bypass, which decides based on what the weather's doing outside and various inputs, it decides whether it's going to recover heat or whether it's just going to bring in fresh air. So that they're not constantly recovering heat. They make a decision about whether they're going to recover heat based on what the weather's doing. And if it's already warm inside, then they'll stop recovering heat. So they're actively trying to target the temperature that you want them to target. So this is just a little video that basically it takes you through one of these ventilation systems, one of our projects. So you have fresh air coming in from outside, goes through the heat recovery core, so it's preheated, and then it's delivered to the rooms at that preheated temperature. So the red pipes are then spreading out to each one of the rooms in the project, and they're being delivered by these ceiling mounted supply valves. So you get a really good distribution of air to every single room. So every living room has a supply, every bathroom, every wet area, every kitchen has an extract. So you're constantly balancing the amount that you're providing via the bedrooms to the amount that you're extracting from the bathrooms. These units come with manifolds, the exhaust manifold. There's also a silencer, so that unit noise from the silencer doesn't travel down the pipes and into the room. So they're also extremely quiet, basically inaudible from the rooms. And then you're dumping that stale air outside. And this is going on 24 hours a day, 24/7. Occasionally you might boost the unit if you're showering or something like that, which means that for half an hour it goes up higher, but you're getting constant ventilation. This is a quick, almost complete photo of that project, but you can see the little mushroom there is drawing in, is exhausting the stale air, and then this little grill below here is what's drawing in the fresh air. So those are constantly doing their thing. So the concept of commissioning, the way I've structured the talk is just to sort of talk through, start at the concept stage, what kind of things you need to consider at concept, then detailed design, and then a little bit about commissioning, and even a bit about project on site. So particularly in the concept stage, I'm going to talk about some of what we've learned. We've been involved in projects with heat recovery for about 12 or 13 years now. Some of the first projects were not super successful, but we learned a lot. So I'm wanting to share what we've learned so that others don't make same mistakes as we perhaps have made. So first thing we learned was that ducts must be within the thermal envelope. Here's our one of our early plans using heat recovery ventilation, and we pretty much indicated to the heat recovery people. We said, look, can you put a supply in a bathroom? Can you put a return in the lounge? But very schematic. Didn't really consider much about what that meant for where those pipes were going to run. And we ended up with this as an outcome where we had foil insulated ducting running through an unheated attic space. This insulation still was to go in the sort of ceiling space. But this ducting was all sitting above the insulation layer. So it meant that if you were getting warm 20-degree air recovered from the bathroom, it was traveling all the way back to this heat recovery core here. And by the time it reached the heat recovery core, it had lost most of the, it probably dropped a degree every meter. And similarly, by the time it was passed out of there, it probably lost another degree every meter. And so while it was moving air around, it certainly wasn't recovering any heat. We also discovered pretty quickly that foil ducting like this is just useless for coordinating with an air tightness strategy. So client had spent quite a lot of money on this Proclimer and tallow membrane, and we found it near or impossible to seal the insulated foil ducts to the Proclimer. So we said, okay, never again. I'm not going to go for foil ducting ever again. Ventilation ducts must be planned. The second project, we decided, right, we're going to go for a European system, chose a Zenda system for that. But again, we left a bit of a services cavity, but we really didn't plan out where the ducts were going to go. And so we left it up to the installer to figure it out. And there were certainly some challenges from their point of view, and it ended up being quite an expensive system. This flat ducting costs about 3 times as much as the round ducting. So if you don't allow much space, there's a serious cost implication for the entire system if you do that. And there were just lots of tricky workarounds. Some of these manifolds really should have been left so that they were accessible. That wasn't able to occur because of the way the install happened. So we thought, no, we need to be planning more and figuring out exactly where these ducts are going to run. So this this plan here is a simple ventilation plan which shows a more recent project. So the ventilation unit here, short duct runs to the outside, but separated by a corner, so it's exhausting out there, fresh air intake here. And then this time we figured out that we're going to have a structural strategy which will allow us to run ducting along this hallway. So all our joists are shallower, and then when they run in between the joists in this direction, we can get into the middle of the rooms and get really good supply. Cam, do you want to jump in at this point?
Yeah, absolutely. So then obviously from a Fantech point of view, when we receive a plan, we have a look at obviously where we're going to locate the unit. More often than not, it's identified on the plan, or we can start coordinating with the designer to placement. So central as possible is always kind of the aim, to keep ductwork reasonably consistent in length. And then we do a commissioning sheet or airflow calc sheet, which you can see on the left of the screen, which goes through obviously wet areas in the red at the top, and that's got all your flow rates and areas for grills, and you can see that on the middle diagram with your red duct runs. And then you do the green, which is your cross flow area. So that doesn't have a supply or extract. It has a cross ventilation, so an undercut on the door, that air is getting pulled through from a supply to an extract. You've then got all your supplies, and then down the bottom we normally select, this is where we select or size the unit, and we're aiming for somewhere between 50 to 60%, closer to the 50% on the nominal operating speed. So that's your everyday running, and allowing that 30% increase for boost is what we look for there. That also gives you a bit of an outline based on the specs of the unit, to do with power consumption per operating year. And then over on the right is obviously more complicated designs, 2-story, where you've got a lot of structural beams, etc., is a great way to sort of detail that up. And as you've seen in some previous fly-through examples from Tim, they do a great job of detailing that right at a concept stage. So yeah.
Yeah, so that really, the central diagram, I guess, really shows that balanced nature. The amount that's been delivered to these kitchen, taken away from these kitchen and bathroom wet areas is the same total that we're delivering to all of those bedroom areas. So the house is not negatively or positively pressurized. It should just be neutral between
And that shows on that
supply and
commissioning
return.
sheet on the left there, those
Those
total
two
numbers.
balance, yeah.
Correct.
So this is that diagram that I showed before. This is what the cupboard ends up looking like with the ventilation unit in it. This is a 350 unit, which means it can move 350 cubic meters of air per hour at its maximum. Nice short duct runs to the inside and outside. Silencer above, ducts running out, and then this is the project when it was just framing, and the builders allowed a big opening there for running all of those 12 ducts. And then here you can see the shorter joists that are going to run along the hallway. So having that kind of all figured out from an early stage ensures that you're not having to come up with solutions on site, or end up having to put in strange bulkheads or whatever to accommodate ventilation. It's another project that uses the same strategy with the shallower joists and heaps of space for running those rather large ducts. The next thing is really to keep the intake and exhaust ducts as short as possible. This is particularly important for Passivhaus projects where you're really looking for high levels of energy efficiency. In the Passivhaus planning package, there is a sheet, a section which looks at this. You input the length of the intake duct and the exhaust duct. You put in a value for the insulation of those two ducts, and it tells you how efficiently the unit will run. And the longer these numbers get, that number starts to drop off quite precipitously. So again, an earlier project, we probably hadn't quite realised the importance of trying to keep those duct runs short. We had 2.5 meters and a 3.5 meter duct. I just checked this against Passivhaus planning package, and it basically, if we had short duct runs as opposed to these long ones, we would have, say, sort of 1/15 of the energy, and that's because these ducts are effectively forming part of the thermal envelope of the building, and they're only 15 millimeters thick. because it's only, you're drawing in cold air out here, and that cold air is allowed right into the unit before it's exchanged there. Again, another project where we located the unit right in the middle of the building. In this case, in order to get through the thermal envelope as quickly as possible, we dropped down to the floor, ducted out the front of a retaining wall, and had a reasonably long duct run here, but certainly would try and avoid doing that wherever we can. I think this project we had kind of realized that we need to keep those duct runs short, so it's right up against the thermal envelope, drawing air straight into the unit and blowing it straight out there. And then you can see these other lines distributing fresh air to the living spaces and drawing it away from the kitchen spaces. Another lesson learned was to locate the unit in serviceable spaces. This was an early project we did, and we were proposing an EVHR system. At this point, we realized that we did have to allow for ceilings to be dropped, and we did our best to figure out where ducting might go. We saw this storage space above the bedroom here and thought, oh yeah, that'd be great space to put our ventilation unit. In reality, this is what it sort of looked like. We had the unit here. There is still a drain which needs to be accommodated under it, so we had to lift that up. And then getting these manifolds and ducts meant that it really wasn't ideal. And then the clients are then expected to get up here every 6 months, pop these capped and replace the filters on the unit. And that's really just, it's not great design, certainly makes serviceability challenging. So also on this project, we learned a lesson about external grill locations. Ideally don't locate them in noise sensitive areas. This unit here was ducted straight out by the front door, and we actually had to come back and put a silencer unit on this grill to reduce the amount of noise that was escaping through that piece of duct there. The newer units are quieter, so we probably wouldn't have had that problem with one of the newer Q series units. But certainly we try and keep the ducts away from, the grills away from areas where they're going to be too close to entries or living spaces. And also try and take the fresh air from the cooler sides of the building. You don't want to be taking air in summer from the northern facade of the building. You'll get, particularly with say a dark cladding, you're getting hot air off there. You're then drawing that hot air into the building, and it makes it much more difficult to keep the building comfortable temperature. So generally try and take from the southern facade, even if there is a slight penalty there in winter. And something I've seen a couple of times is locating NVHR units under stairs. There are a huge amount of ducting associated with these things, so you really need to think about how that ducting is then going to escape from that space, and stairs certainly make that pretty challenging. Even at the concept design stage, we generally do a quick unit selection process just to understand whether we're talking about one that's located in a cupboard or one that's located in a ceiling space. And according to Passivhaus standard, you need to choose the greater of these three criteria. So either 30 cubic meters per person, or a total of all the extract demands, which is, you basically work out how much all kitchens and bathrooms need and combine those together to work out what the maximum is, or 1/3 times 1.3 of the volume of the building. You don't have to remember this. There's a slightly simpler rule of thumb, but in the Passivhaus planning package, you can see that illustrated in the ventilation sheet here, where it talks about 30 cubic meters per person would result in this much demand. But when you add all the bathrooms and kitchens together, you end up with 140 cubic meters demand. And it also looks at the volume of the building, but it tells you that you actually need 140 cubic meters for your maximum airflow rate. And it's your maximum speed is not the speed you run on all the time. You use 0.77 of that maximum speed is what you typically run it at. That's the boost function. And then if you're away, you can leave it, you can put it on the low setting, which will be at 0.4, just turning over a little bit of air. And it's important to point out that these units do want to run at about 50 to 60% on medium speed for longevity and acoustic reasons. So a rule of thumb which you actually might be able to remember would be the volume of the building times 0.3. So basically a third of the volume of the building equals what you need to be moving at medium speed. And then you double the size of the unit so that you're running at 50%. So for example, if you had a concept design stage, you realized that your house was going to be in the order of 400 cubic meters, you need to be moving 1/3 of that, 120 cubic meters per hour. And therefore you would need a unit which is capable of moving a maximum of 240 cubic meters per hour. So that tells you that you probably, you're going to be using one of the slightly bigger units rather than the smaller ones.
Just jumping in on the acoustic side, really important, we touched on before and Tim did on the percentage of operating speed, which you can see down on the left there. So this is for a Q350 in the data sheet. So you can see on the next one, the test area, next column, you've got the casing, so breakout noise, and then supply and exhaust ducts off the unit. So we won't get into octave bands and sound power levels. It gets a bit complicated, but essentially you're looking at the decibel of acoustic rating at a 3 meter point. So obviously in a cupboard, that unit on a nominal speed is barely going to be audible, which is the number out on the right. Couple of different unit options we've got. So you've seen a few photos of the vertical, which is our most common Q series unit. So we've got a Q350, 450 and 600. And then on the right is a more newer technology. We started supplying that into the New Zealand or Australasian market about 18 months ago, 2 years. And that's a in ceiling, so you can drop a scullery or laundry ceiling, or as Tim's shown before, sort of just design around having smaller joists or rafters in that spot, which then creates a roof cavity to put that in. You do need to have a bit of a access hatch, obviously, for maintenance, filters, that kind of thing, and also the ducting coming off each end. You got the silencers down the far end, with your ducts running off for supply and extract, and then your external duct runs as well. So just planning that so it goes to the exterior of the building as quick as possible.
So we're really, an architect, pretty familiar with Zender units. So all the projects you probably see here will be Zender units. And so when you've figured out your sizing, we would tend to then go and then look at the different option units available. So Zender Comfort WEO 180 is capable of moving 180 cubic meters of air an hour. So it's a great option for a 1-bedroom or 2-bedroom unit. And they can be accommodated in cupboards. Have to be really careful to make sure that these little hatches are available, because clients will need to be opening those to change the filters every 6 months. And for maintenance, these panels need to be accessible to be able to be taken off to access the heat recovery core inside. The next unit up is the Zender Comfort 200. It can move 200 cubic meters of air, but should run at 100 cubic meters at 50% typically. You can run it in a vertical or a horizontal format. These things are the filter access panels. You also need to have an access panel which is big enough to accommodate these manifolds. So this is all the air coming back from the bathrooms, and this is the air that's going out to the bedrooms. So those should really be accessible, so that one day you can come in there and give them a good vacuum out if they would ever get dust and things in there. And then the bigger units are the Comfortware Q350 to Q450 and Q600. These units always sit in this format. You can either have them so they duct up through the ceiling, or organize them so that they turn over and you're running manifolds back down through the floor.
Comfo Climb, I saw a question pop up from Joe actually, so this one sort of touches on that. The Comfo Climb is the unit sitting on top of the Q series, the air handling unit at the bottom. It's got a compressor in it, which does heating and cooling. So it doesn't have any external compressor. It's all built in to that one unit sitting on top. You've got a condensate drain running off the left-hand or right-hand side, depending on the orientation of the unit. And that does a small amount of heating and cooling. So you're creating a ducted heat pump, if you like, on top of your air handling unit. Some things to bear in mind, obviously pricing compared to doing a standalone heating and cooling system, whether that's high wall split systems, ducted, and also airflow. So with moving 0.35 air changes typically per hour on an MVHR, you are moving a lower volume of air, but constantly. So it's a matter of making sure that the building envelope, if we're looking at a passive house, and the passive house planning package, looking at that heating and cooling load to make sure that we're adequately going to be able to service that at the peak demand that it calls for. So pretty selective on what projects these go into. We've supplied 7 or 8 of them in the last 18 months. So not a massive product mover for us, but it definitely addresses some projects. And then on the right hand side, you can see there, you've got supply ducting on the left. If you wouldn't mind just pointing that out, Tim, the dark ones, yep. So those actually have a wrap around them, so a thermal wrap. So even when they're running inside the air tightness and thermal layer, they have an additional pipe lagging around them. Comfo Therm is the name of that product. So that's just on the supply side to make sure that we're getting the hot and cold air through to the exit point rather than getting losses in the system. Obviously on your extract side, we don't need that as much. It's not as critical based on condensation points.
So when you reach the detailed design part of the project, some I guess really reasonably sort of technical kind of things. Plan for condensate drains. Make sure the VHR unit is on the plumbing plan. Plumbers need to know that they need to allow for a drain for this. These units come with dry siphons so that they release a lot of condensate in the winter, but during the summer much less. And so if it's just a typical U-bend or U-trap, they can dry out and then they can start sucking smells back from the sewer. So they have to be this a dry siphon option. I don't know how many jobs we've had where we turn up and they've installed typical traps and we have to ask them to change them over. This one is an alternative HEPO dry siphon as well that prevents smells being drawn back through from the sewer. Pretty careful consideration does need to be given to condensate drains for these Comfort 180s. When located in a cupboard, that condensate drain needs to be plumbed into the wall and then needs to be then run down inside the wall, and under the sink it gets plugged into another dry siphon here, which gets plugged into the trap. So it's essential that that dry siphon is there. If it's not, again, the unit will start making glugging sounds as it starts to sort of suck air through this trap. Strategies for duct distribution. There are various ways of getting ducts around your building. Just want to iterate again that they are large, so they have to be planned for, much like plumbing. We've talked a couple of times about structural systems, which where you just reduce the depth of the joists to allow your plumbing and your ventilation to run where it needs to go. Better to plan this out in advance. In this job, we asked the engineer if we could put a 100mm hole through the high span. He was more than happy to let us do it, but it's just stuff that doesn't need to be solved on site. And then typically for single level homes, you can get away with a system where you have an insulated a services cavity below the insulation and the air tightness layer. This particular solution here, we have a bracing wall, which we have a detail for, so that we can block off 100mm below the top plate, and it can provide our bracing, but we can still let our ducting run over the top. You know, bracing walls can be a real challenge if they run all the way to the top plate for getting ducts through buildings. That's our standard detail there for how for our single level homes. And of course, you've got different options for ducting, but again, there's a significant cost premium for the flat ducting. So we tend to try and use the white ducting, and we tend to try and design systems so that the white ducting is continuous from the unit all the way through to the valve, just so that when, you know, at some point in the building's future, ducts will need to be cleaned, and we want to make sure that that's going to be as easy as possible. There are options for using truss type floors. They're not without the challenges. You still probably will have some beams that you have to work your way through. There's a couple of townhouses we did here with ventilation systems located on the top floor, distributing through the ceiling, with vents and exhausts in the top. We actually created plywood boxes for the ventilation unit to sit in within the trusses and make sure that they were nice and airtight. Ducting running through the truss floor, but you will occasionally strike structural members that you need to get through, but fully coordinated with the plumbing, making sure that you're not you're avoiding clashes on site. And then that's that solution there with the unit tucked into the box. And so when the air tightness layer goes in, it all gets all taped together, nice and draft proof, heaps of insulation on top, and can sit there in a stair landing, not taking up any covered space, but still be really nice and accessible. There are some good solutions for getting under beams at times, seem to have some of these options. Another wee 3D model of a ventilation install. We've got lots of Comfort 200 options here, but so drawing and exhausting from this combined grill here, again really close to the thermal envelope, so we're not traveling through the building for too long. Plumbing's all been modeled so that we know we have to get, I've got a bathroom above, we don't want to be having clashes with that, and then just figuring out how all this ducting is going to go, and various risers and things like that we need to put on to avoid site issues. In this particular job, we scratched our heads for a long time about how we were going to get a supply duct right to the end of the living space, because you do want to get the air right to the end of the living space so that you're then drawing it back to the bathrooms and getting really good air movement. You don't want to be short-circuiting by having large bits of the room that aren't sealed. And in this case, we just opted to put a whole bunch of joist stiffeners in. It's the easiest way of getting a single duct from one end of the building to the other. Better work on site, but probably the easiest way to do it. And that's what the unit looked like installed in the laundry space there. And again, you've seen that photo of how it sits above the laundry. Another 3D, this time of a Comfortware 350, located downstairs in a 2-story building. Whoops. Same kind of strategy of making sure that the structure's been figured out with all the ducting in mind, making sure that we've got our plumbing working, and that we're not going to have any real showstoppers on site where we have to, again, put in bulkheads or something like that. And then fully coordinated with the space. It gets a couple of valves coming out here. Next point in the detailed design stage is just valve and grill selection and location. Zenda do have a range of grill options available off the shelf. Your basic sort of ceiling one, and a couple of other powder coated metal ones, and a more recent linear grill. The ceiling ones, they're not everyone's cup of tea visually, but they are really good at spreading air from in a room. Located in the center of the room, they basically spread the air along the ceiling. The air sort of sticks to the ceiling, and it travels right to the edge of the room and then drops down. Important not to locate these too close to a wall. If you don't want air dropping down on, say, somebody's head, I definitely wouldn't be having one located there, because these people would feel air movement along that wall. But there are things like the air blocker component here, which you can add to these, which will block a certain part of the vent and say stop the air moving in that direction, so it'll just focus on the other 3 sides. Floor mounted grills as well are also an option. They do need to be carefully located away from areas where you might put furniture, or where they're likely to get trampled on too much. And then there are third-party options for linear grills, some even involving LED, horizontal, vertical. And if you want to get really carried away, you can add bespoke solutions as well. And various options for external grills. This is the combined one that we discussed before. This comes from, typically you would locate your grills a minimum of 2 meters apart. This piece of kit allows you to have the intake and the exhaust right next to each other. They've done a lot of really good modeling. It's ended to prove that I think 6% contamination occurs even in really windy conditions with these grills. So exhausted out this one, and then it's drawing in air in to the intake there. Or there's some more standard grills, stainless steel grills. And again, you can really, there are options for customizing as well, but you have to consider serviceability and those options. And my pet thing, drying cupboards, fantastic for, you can, basically hang your clothes in a cupboard, and then within 24 hours with a grill in that, with a return valve in that cupboard, they'll be bone dry, and really avoids having to worry about New Zealand's variable weather. So on site,
I'll let the video play and then I'll talk to this.
one of the things that did attract me to Zender products was the fact that they are so easily, so easily modifiable. Like sort of clip together, they can unclip if you need to unclip them. They are very user friendly for builders on site. So lots of great features that make them really a good option.
Yeah, so the reason I popped this video in is a new development from Zender. So these used to be a metal slide clip that went over the ribs of the pipe. Now they've designed it so that you push the pipe directly in, as the video was showing. So it means on site and the secureness of those pipes, you can push them in without pulling that red clip out. So you literally push it down and it clicks in nice and snug into place, which saves a lot of time. And if you've ever seen an installation or installed one, when you've got two manifolds sitting front and back on a unit, that back manifold can get quite tight. So being able to push the pipes directly in is a really nice feature.
So just a few sort of tips for on-site. So challenges with air sealing. It's great to sort of make up custom grommets. You can use a bit of butanol to make your own grommets to suit pipe penetrations like this. That way you get, really good airtight and weather-tight seal around junctions. We find that birds love making nests in these things, so it's also a really good idea to put a bit of a cover on them. Numerous times we've turned up on sites and seen birds making their nest in these units. When we design systems, we generally avoid punching through the air tightness layer, but occasionally it's unavoidable or it's the best option. It can be done, it wants to be done really carefully. There's a lot of insulation that's sitting behind this that's covering the pipe to keep it warm. But we are popping through the air tightness layer there. We've got a grommet here, another grommet here, and then the junction behind these all been taped up as well. And similarly with this project here, where we're running our ducting inside the insulation layer, or as close to the inside of the insulation layer as we could. And then when we pop through the entire layer, we're making sure we have some grommets there. These grey pipes get cut to length when the sealing goes in, but they remain covered until you pass the dusty part of the project. And just another important part about design is those penetrations it's really important to leave space around them so that you can do a good job. If you're relying on your pipes being hard up against structure, it's extremely difficult to make them airtight. So thinking about that at design stage is really worthwhile. And just briefly, there are a couple of the components. Zender is a system which is designed to work in a European context. So there's a few components that I think these things are sort of supposed to work in masonry type walls in Europe, but so there's a bit of modification that's required to make them work with a timber framed system. And then commissioning, really super important. We do this ourselves. Here's Sam from our office with an airflow meter. We go through, measure the air that's coming from each of the valves, and we set them to the level that we want them to be set to, 20 cubic meters of our a medium setting for the study. Guest bedroom, you can have a supply of 20, and then again these numbers are sort of adding up. So you have 180 cubic meters supply and exhaust. These little devices here are called comfo sets. They are a slightly older way of setting the flow. So you put the right size ring on them and pop them inside the duct, and they reduce the amount of airflow so that you can actually achieve a lower amount of airflow in a particular room, and that forces more air to other rooms. So you need to optimize them to work. Well, that's very exciting. I'm just going to briefly. Cam, do you want to just quickly jump in about the lunar valves?
Yeah, so the Lunas obviously have pretty good adjustment. That there's a extract, so it's got a cone shaped, so the air flows up nicely. It's both visually from the ground, they look the same. The supply has more of a thinned effect, which we looked at previously, that shoots the air across the surface of the wall. And you've got many adjustments on those that you can actually adjust on site. The Comfo set you would use mainly for grills that don't have this adjustment. So the Lunas are actually really good to get the adjustment. You don't want to close them up too much, like any grill. There's the cover going on because you will get sort of noise of whistling effect if it's starving itself of airflow. But you shouldn't have to close them up too much. But visually, they both look pretty good. They do come in black as well. As white as standard. So it would be the majority of what we sell as the Lunar grill, and a lot of custom linear grills and things are becoming more popular.
Yeah, they certainly make it very easy to commission the system. You just measure the airflow, knock it back a bit, measure it again, knock it back a bit, and then get set it to exactly what you want the outcome to be. And if you do it right, some monitoring which we did on one of our projects a couple of years ago, you should be getting most of the rooms within this sort of 40 to 50% relative humidity band. There's definitely a few outliers here that probably need to go back and measure exactly what's going on with those ones. But we're aiming to have relative humidity between 40 and 60%. And CO2 also, we want to be making sure that trying to keep that generally below 1,000 parts per million, which is sort of recommended from World Health Organization. So there's a few of these rooms that are slightly above that, particularly this one. I want to go back and have a look at what's going on with that, but we're seeing pretty good levels of fresh air being supplied to those other living room spaces. Control-wise, the kind of Q range have a phone app, which is great. It tells you a lot of information about what the outside air is, and you can boost your unit from wherever you are in the world. And some of the other units have a wall-mounted ComfoSense control panel, so you basically just have to sort of turn it on medium or high, and then it'll give you a reminder when to change the filters. But there's not a lot of messing around required control-wise. Maintenance, super important. Filters need to be changed 6 monthly. Set of filters here. This one is the outside filter, so this is particulate from outside environment, maybe cars or pollen, whatever. And this unit here, this filter here is cleaner. So this is the one that's protecting the ducting. So yeah, it's typical to see the outside one full of bugs and looking pretty black after 6 months, while the other one is a bit cleaner because it's really just the internal air. Super important and often forgotten, cones do need to be put on all the bathroom return valves, or any of the return valves, because we want to be keeping the duct work as clean as possible. So putting a valve on a filter cap on that stops those ducts getting dust drawn in from the room. And just briefly, this is how those cones sort of work. So this also needs to be done every 6 months by the building occupants. That is not very dirty compared to how frequently they can be very dirty after 6 months. So it's pretty important to stay on top of that. And that's really the presentation. here's a couple of a few projects which we've done in the last few years. We really encourage all of our clients to put ventilation units in wherever possible, and really think it's important to make sure these are really well coordinated to keep them affordable and keep them functioning properly. So I guess we're into question time now, are we?
Yes, thank you so much, Tim. That's awesome. And Cam, that was fantastic. Lots of incredible information there. And we do have lots of questions. So I will run through those in the chat. Okay, so kicking off with Paul, he's got 3 questions. So he says, is there any influence on performance of the overall system if the ducting is straightened out versus left slightly coiled?
I'm going to leave that to Cam.
That's the internal ducting, I'm assuming, so the white ducting. Again, looking at sort of the overall layout, you do want some soft bends on certain ducts. You don't want a whole lot of sharp 90-degree bends because you will get resistance. But definitely softer bends help with noise as well. And then the second part of that question was suggested service intervals. So for our units, the filters in the unit itself every sort of 6 months. I normally get clients to have a look at them after 3. It will notify you on the app or on the unit or wall controller, because they, after 3 months, depending on the season, they get pretty clogged with insects. So you can give the filter a quick vacuum on the supply side and then change it after 6 months because they're a paper filter. You can't clean or wash them on the unit, and then the housings every 6 months as well. Value in having ductwork cleaned periodically. So 5 years, 5 to 7 years is normally the heat recovery course, so more of a full overhaul of maintenance. So the heat recovery core you slide out, put in the bottom of the shower or outside, put some warm water through it. You don't normally use detergent, just until it runs clear. To be fair, a lot of the units that I've seen after 7 or 8 years, the heat recovery core is actually remarkably clean. And that comes down to sort of the maintenance. If it's been well looked after in terms of filter changes, typically that is pretty clean. Ductwork, again, 7 years, but if you've used your filter Smurf hats, then most of that sediment or dust accumulation will be caught at that point, which is really easy to change out rather than it getting in your ductwork, and then you have to use a duct sweep tool like a chimney sweeper that you slide through the ductwork and pull it back out towards the duct opening. I think that
Awesome.
answers that one.
Thank you. A question from Kat. Hello, Kat. Have you had any experience with balancing the air source location, summer versus winter? We are slightly more cold days than hot days, so the bias is towards heating the incoming air, not cooling it. So Kat's in Wanaka, just so you know. So that would be to do with locating the outdoor air duct, whether it's
Yeah,
on
so
the
the external grill, definitely placement of the supply, always recommend on a wall rather than a roof cowl intake, and not on a north or sort of northwest facade, normally on a south facade. So you get more of a even incoming air temperature throughout winter and summer.
I mean, you can go into the controller and you can opt if you want it to be slightly cooler in summer and winter. You can choose
From a
what your
profile.
yeah, from a profile setting. So you can say, oh, actually my preference is to make sure it's 20 degrees, and so the unit will try and target that. Or you can say, actually, I prefer it to be 25, and so the unit will target that as well. So it just affects when the bypass goes on and when it dumps here.
Awesome, nice. It's a question from Alistair. What's the minimum separation distance between external inlet and exhaust vents?
You're looking at about 1.5 to 2 meters if they're separate grills, or if it's on the corner of a building where you've got the unit in the cupboard, you can have the supply coming out one corner and the extract coming out the other. If you're looking at a combined grill, obviously, there's Zender specific FSI data on that. Even with a direct wind, there's less than 3% contamination, so they work really effectively. So separate grills work on about 2 meters, or you can go to the combined if that's a complication to get them separated.
Awesome. Hello, Joe. He says, some questions I often get from clients. Can MVHR systems adequately move heating or cooling from one space which has a heat pump in to another that doesn't?
I would say not all the time. Certainly, if you've got some spaces which have a lot of solar gains, that they don't move that much air.
Correct.
Yeah, they will stir the air over a 12-hour period or something like that, but they're not, they can't be relied on to move that much temperature around the house. Yeah.
Yeah, normally what I say is they are not a heat transfer system taking directly temperature from one room to another, like used to have a heat transfer from a fireplace through to back colder bedrooms. They're definitely not like that. Their primary function is obviously fresh air ventilation, and then their heat recovery is obviously where it comes into taking that out of its extract. So it will do a small amount, obviously, to maintain up to that 90-something% heat recovery, but it's definitely not going to be effective at moving, 17-degree air if you want that in summer, trying to drop it down in other rooms.
And it's also important to realize that it's not measuring, you don't have zone control with these systems. They basically aggregate, all the ducts from the supply rooms come together. And so it works, it basically averages all that air gets combined together. It averages it together,
Yeah.
sees what that temperature is. It can't see if one unit room is receiving a huge amount of sun and is a lot hotter than another room. So that's where you need to look at shading strategies for those individual rooms.
Yeah, that's a good point.
Awesome. And then Joe's second question is, how are MVHR units with dealing with humidity in our more humid climates?
It's a topic that I get asked about very frequently. You can look at sort of other strategies going away from a heat recovery core to an enthalpy core. Obviously, the New Zealand climate more leans towards a heat recovery core, so that's typically what we do sell into the market. And second,
enthalpy lets a bit of moisture across the core, doesn't it?
correct.
Yeah.
It retains that moisture in the
Doesn't.
core.
Yeah.
Yeah. To help with that humidity control. Secondly, the Q series has obviously the sensor and humidity probes in it, and it's constantly trying to maintain that set point so you can have humidity control on. So if it feels it needs to boost or drop down slightly to its nominal speed, then it will, to try and maintain that humidity comfort level.
Nice. Got lots of questions from Jonathan. Hi, Jonathan. So first question for Tim. Could you talk to any fire regulation considerations, if applicable, when using MVHR systems, for instance, in the co-housing project in Dunedin?
Yeah, multi-unit wise, as long as you're not putting penetrations in, I mean, you'd need fire collars if you're going to go through any firewalls. But if you're going to put an individual unit in individual homes, there's no real problems. It gets a bit more complicated when you start to be wanting to run ducting from unit to unit, having one unit which services more than one fire cell. That starts to get a bit more complicated because you need to make sure that it's going to, shut off in the event of a fire, so it's not going to be drawing smoke from one fire cell through to another. So yeah, there's definitely some challenges with that, and I think it's really, when you are doing multi-unit projects, it's pretty important to have those questions answered at the concept stage, because if you don't want to be finding that all of a sudden you're putting a big penetration through a firewall and there's no room for a fire collar there, or yeah, there's definitely needs to be thought about up front.
And the other thing as well, if you've got a main residential home that say has a granny flat or a studio apartment downstairs or separate in that separate fire space, then we normally actually put a decentralized unit typically in there and try and treat that area separately to the main dwelling just to keep it more simpler.
Cool. So next question from Tavis. Is it possible and practical to incorporate heating coils from a separate heat source into the supply stream?
It has been done and done quite commonly in commercial sort of hotels and things where you have a fan coil unit into the room that you have a set point temperature, and then you're obviously pushing that air over it. So you're either running hot or cold water through that coil, and then you've got, in some cases, a fan in that box as well that's assisting to boost that air across that. So it is a possibility, not widely used in residential at all.
Yeah, you have the challenge that we are moving very small amounts of air, 30 cubic meters per person, or, it's not huge quantities of air, and it's only possible to put so much heat into each cubic meter of air before you start to get burning type smells coming from the ducting. So it can be done with passive houses. If they're designed right, you can put enough heat into that supply air that it distributes it, but it's pretty challenging.
So the second question from Jonathan is for Cam. Wonder if you could talk to considerations that need to be taken into account when undertaking blower door tests during construction and at the end.
So I'm probably thinking that he's meaning ducting, so external penetration, so your intake and exhaust. Normally either taping them with a tallow on the exterior. Obviously, there's a volume there for the PHPP, and maybe Tim can talk to that a little bit as well, that if you are doing it at the end, you should actually terminate the vent as close as you can to the ventilation unit because of that volume of air in the external ductwork. So normally I will put on a Q series, which you can see there, a piece of Intello. I pop the joint out, put a piece of Intello in and push the joint back in, which completely sandwiches the Intello in there and completely airtight, and a lot better result than taping up the exterior grille.
It is an important consideration. You certainly need to be able to. I mean, most of these installs here, you can see, you could say pop one of those elbows off because they're just friction fitted together. Pop one of those off, seal it. We often use like an inflatable ball to just pop inside the duct during the test, and that means that you don't have to consider the ventilation unit at all because if that's the thermal envelope, you've sealed it and you're good.
Yeah.
So Alistair has an observation. He says he was staying at a friend's newish house near Twizel recently. Very windy, extra high wind zone, so not very practical to have windows open. With no ventilation system other than a bathroom extract, the log burner performance was comprised, even with a double skin flue, roars into life if windows were opened. Guess this is a problem in many places with improved sealing on modern builds, so more airtight buildings.
Yeah, it sounds like a typical situation where you've got more of an airtight structure and poor internal ventilation, unfortunately. Sort of almost a positive pressure situation going on.
Yeah, something to consider when you're using, we do some projects where we have range hoods that are ducted outside, and you do have to consider that you absolutely need to make sure that people open a window or something. If you've got an airtight build and they turn the range hood on, it's drawing a lot of air out of the house, so there needs to be somewhere for that makeup air to come from. So you probably need to organise some sort of valve to be put into the building structure, or make sure they're aware that they need to open windows when they do that.
Mm-hmm.
Cool. Matteo, hi Matteo. He says, can you give us an idea of the premium for the heat pump unit that sits on top of the air handling unit? Also, is the exhaust hot or cold air coming out of the heat pump directed outside of the building envelope?
So the first part, depending on the unit itself, a ballpark you're looking at sort of somewhere between with the other upgrades that you need to the insulated supply ductwork, you're looking at around 12 to 15,000 from a retail point of view, on top of your air handling unit as a ballpark. So they're not an extremely cost-effective option, but then you don't have other terminal vents and all of that sort of thing to consider if the building envelope will allow that unit to work. The second part of that question, again, Jess, was
around where does the outdoor air for the heat pump, how does that get out of the building? The exhaust air from the heat pump.
so same as what it does on the air handling unit, you've got an intake and exhaust. So when that air comes back from the return points within the home, it's coming back through the unit, it's doing its heat recovery or bypass, and then it's dumping it outside through the same exhaust grill.
Awesome. And then another one for you, Cam, from Jonathan. Wonder if you could talk to maintenance, cleaning, or other servicing of the MVHR system. I think we've covered that mostly.
Covered.
Is there
Yeah.
anything that you want to add to that?
No, I think we covered that.
And Matteo wants to know, saying Tim, for your the videos you had there.
Sorry, we wanted to know what?
The software
Oh, the
that you
software.
use for your fly-throughs.
ArchiCAD with using BIMX on the iPad. Yeah, just recorded off the iPad.
Nice. So Belen, you get the prize for guessing that. Yeah. And another one from Jonathan. Wonder if you could talk to the inclusion in the MVHR design of an air handling unit preheater in the various climates in New Zealand.
Yeah, it's in the Q series you can add it in. It's because you can change the handing of the unit from a left or a right, so that's the side that the intake or exhaust is coming in from. So you can see in the collage of photos there's some left-handed units and right-handeds, and you slide the element, you take the front cover off and slide the element in, and it's a plug and play. And that's, like I always describe it, as antifreeze in a car. It's purely for the air when it gets below zero. It will decide if it needs to kick in to just pre-warm that incoming air before it hits the heat recovery core to stop that heat recovery core from freezing over. So obviously minus outdoor air, you've got potentially 20-degree indoor air getting extracted back through the heat recovery core. You don't want those two to freeze over. So that's purely a mechanism to try and stop that happening. In terms of climates, anything really in below Christchurch, I will make them mandatory, and the rest of the quotes as an option. I know coming from central North Island and Reparoa, etc., it gets some pretty gnarly minus frost there, and even in the Hawke's Bay. So it's really an option to add it, and it can be done retrospectively if it becomes an issue later on down the track, which is good. Some of the other units like the Comfo Air 200s and 180s, you have to order them us as supplying them with a preheater or not. So normally look at that pretty closely given on where the project is.
Awesome. And I'm just going to jump ahead to Nigel's question because it's related to that one. He says, are there any external grill heaters to avoid freezing air blocking the grill? So those preheaters, will they prevent the grills from getting blocked with frost?
Yeah, I think the only thing to sort of comment on that would be is I am aware of one, Nigel and Alexander, that had a issue, I think, last year. And my only thing thinking about that is on the supplier intake, again, maintenance is just making sure that there's no debris stuck to that. Because if that's already somewhat clogged on the bird mesh, so that's to stop any bigger sort of pests coming in than moths or bugs, is that if that's got some debris sitting on it, and then you have these -degree sort of lingering cold patches, then that will freeze over. Whereas if it's completely clean and clear, typically it shouldn't. And I've only heard of that one down your way that's actually had that happen. So not specifically a duct heater that I'm aware of. It's more the preheater when it just for the core protection.
Awesome. David asks, is it possible to sense humidity in the rooms and activate Boost with the standard kit, or is a third party like Home Assistant required?
You can do that as standard. Obviously, it's more of a cumulative number back at the unit that it's picking up on the sensor. But you can add third-party sensors, KNX, or even just little sensors that you can run a simple 0 to 10 volt input back to the options box on the unit, which triggers a boost function to help move that air through. So kind of both options. The third party is typically more effective in a bathroom. For example, if you didn't want a manual boost and you just wanted it to pick up humidity, you can put a wee sensor that's triggering through HomeKit or the 0 to 10 volt input.
Yeah, it's probably worth mentioning that typically you would have a boost, especially for these.
Correct.
For most, the 200s and the 350s, you would have a boost button in each of the bathrooms. That's a PRISMEX switch. It's got a cable that runs back to, that sends a signal back to the unit, and the whole house ramps up for 30 minutes when you push that button, and then goes back down again to normal, and that just clears condensation after a shower and things like that.
Cool. Another question from Matteo. What happens if rainwater enters the air handling unit from a roof fresh air intake? Can the unit handle some water, and how quickly would the filter dry out?
I would say a very minimal amount. Ideally, if that's happening, you want to have a look at the cowl on the roof. And I would recommend to always have a supply where possible through a wall, but look at the apron flashing on the cowl to make that slightly longer to stop that rain getting in, but not something that it will handle very much of in terms of drying out that filter, because because it's sort of quite a warm environment in the heat recovery core. If that doesn't dry out, then you've got potential that it could cause some mold issues inside the unit. So you definitely want to tackle that from the root cause.
Certainly all your pipe penetrations through the walls should be falling to the outside, so if moisture does get in there, they should then drain back out again to the outside.
And I think you did say that your preference was to have the fresh outdoor intake
Through the wall, through an external facade, yeah, rather than the roof.
Cool. So another question from Nigel. Do you have a preference for location of internal vent grills in a room, floor, wall, ceiling?
Normally,
yeah.
You go, Tim.
Well, I mean, the Lunas I don't find them visually offensive or anything. We have had some clients that go, no, we don't want this little disc on the ceiling, but they're great because they do give you really good distribution. If you locate them too close to a wall, you will get a bit of dust forming on there, so they're supposed to be kind of spaced off the wall. I mean, it's kind of what people are into really. The third-party grills do cost quite a lot, but.
And just jumping in on that too is obviously from our point of view as an acoustic and noise thing, we can kind of give you data on what a Luna grill will do with a complete system. Whereas if you start adding aftermarket grills and things, it gets really complicated after the unit silences what noise levels are doing. But rule of thumb we work on is you want to go to the opposite corner of the internal door, and you want to be away from a bed head so you get that sweeping effect back through a room.
Yeah, probably also
Ideally.
worth noting that a lot of your doors will need to be undercut 10 millimeters, and that needs to be marked on the ventilation plan as well, just to say, look, the air is actually going to be coming under these doors and back out and then into the bathrooms, which also need to have undercut doors as well. So there's that circulation of air occurring.
And just a compliment from Elrond, he really likes your array there of installed systems, Tim.
Thanks, Harold.
Nigel asks, how often do you need to access the external grills?
I would check. It's always good to try and do a visual check on those when you do your filters. It's quite an easy reminder to do a visual check. If you can't easily access them, I would be doing it kind of every couple of years. I'd definitely be visually trying to get up there and have a quick look at them just to make sure that they're not blocked in any way or debris stuck to them.
Nice. Tim would like to know a typical design and installation cost for, say, a typical 180 square metre 3-bedroom home.
From a supply point of view, you're probably anywhere early to mid-teens, I'd say, on supply of gear. And in an install, you're probably somewhere, it's always a hard one. Some of the installers out there, I hope they're not listening. Tim, maybe you can comment on that. It keeps me clean.
I don't see, we've done a few of these, quite a few of these ourselves. We tend to think there's about 3 days work in it most of the time if it's been designed properly. It can be a lot more if it's been designed poorly. So I think it's one of the messages of if you include it at the design stage, it makes a massive difference to the cost of the system. And if you're having to solve stuff on site and build out bulkheads and do all kinds of weird stuff, it can really go up. So
Yeah, 3 days
yeah,
I think is a fair for 2 guys typically. So
yeah.
obviously pulling ducting, you need 2 people, one on each end. And then whatever that sort of hourly rate is, it normally ranges from sort of $60 to $100 an hour, say, for example, depending on if it's an experienced labourer or an apprentice.
Awesome, thank you. And just a compliment from Paul. He says, excellent info, nicely flowing presentation and good visuals. Elron says, I was taught in the Passivhaus designer course not to put intake exhaust terminals around the corner or on different facades, as the wind or air pressure can be very different and imbalance the MVHR. Doesn't seem to be considered an issue though. Can the MVHR cope or self-adjust?
Yeah, definitely on the Q series, because they're a self-balancing fan, they will actually pick up that indifference in pressure and balance themselves.
And it's also worth considering how exposed that corner is as well. You know, a lot
Yeah,
of these examples, they're sort of really out of the wind.
southern
So it's
facing.
yeah,
Yeah.
yeah.
Cool. Joe says, thanks team. Richard, hi Richard. He says, when cleaning the internal flexi duct work, how dirty have you found them after 5 to 7 years? And how do you clean the rectangular style flexi ducts?
So Zenda do a duct cleaning kit, which we lend out on sort of loan for our systems, and you feed that through. You can attach it to a drill as well, which sort of spins it to break any debris. And as you slide it back towards you, you hold a vacuum cleaner up and grab that out. After 5 to 7 years, again, going back to the Smurf hat ducts, if those have been regularly used and maintained, not dirty at all. I have seen one recently that I was actually shocked how clogged it was, and they hadn't used a filter. It was on a kitchen, and I don't think there would have been any airflow going through there. So that's the flow-ons of not using the Smurf hats. And it was, yeah, I should have probably put that photo in there. I couldn't believe it. I rang the person straight away and said, where is this grill? It was completely clogged.
Okay. Okay, so there's a bit of discussion around using low energy trace heating cable to add to the external grill to keep it free of frost.
Are you essentially meaning like a underfloor, under tile heating type trace heating cable, I'm assuming?
Your guess is as good as mine.
Yeah.
Sorry, Richard. Do you want to chip in, Richard?
Yeah, they use it for pipe systems, mechanical pipe systems on the exterior of buildings in low temperature areas, and they run trace heating cable, and it's a special cable, a resistive cable that warms up, and you can use that, and it's quite low
Okay.
energy, and you can use that on exterior grills. But of course, you've got to run a circuit out to them and get it back again. It's got to be protected, and you need some sort of sensor because you don't want it to run all the
Thermostat,
time.
yeah.
Yeah. Okay.
Yeah,
Cheers.
interesting.
So Nigel just wants to know, is there a preference for combined or separated external grills?
I will spec either. Quite often it makes sense to do a combined grill. Some people do have a preference to go separate, and I'm fine with either. Tim, you've done a combination of both, and both have given good results.
Yeah, I mean, I visually I prefer to avoid the combined ones. I just think they're a bit more obvious on the outside of a building.
Yeah.
So where possible, we try not to, but they're a good solution where it's unavoidable.
Cool, thank you. And last question from Nigel, are there any minimum or maximum duct lengths? So that would be for the supply and extract ducts.
Minimum duct lengths, you really, especially for a supply close to a unit, you really want it, I would say, between 5 and 7 meters as a minimum length. And again, dependent on the size of the unit. And it has a bit of a flow on. If you've got some longer duct lengths than you usually would, then those shorter ones actually make a big difference to make sure that they're slightly longer than your bare minimum. In terms of the longest, 20 odd meters, when you start getting over that, you want to kind of start looking at, is the unit placed as central as possible? But sometimes you can't, avoid some like that, but it's just a matter of then balancing when you go to commission. It's a bit of a harder job. So it's definitely a bit of a massaging game in terms of getting that unit in the right place with certain duct lengths, short and long.
Yeah, yeah. I mean, I think it is important to note that those longer ducts will have a lot more resistance on them than the
Correct.
shorter ones, and that's part of what the whole commissioning and balancing the system is intended to do, to make sure you restrict those short ones so that they're not just taking all the air and leaving none for the longer ones.
Lee has left a link to an article on alternatives to door undercuts. But we do have a few minutes. Do either of you have any other suggestions for transferring between zones other than door undercuts?
I mean, door undercuts are very cost effective, particularly if there is carpet. Acoustically, that works quite well. A 10 mil door undercut won't let a lot of noise through. If there's a hard floor under it, there will be more noise that bounces under there, and so you might want to consider alternative options. But we generally find, but you absolutely need to make sure the builders do it as well. So it's part of the commissioning process is to close the doors and make sure that the system performs the way it's supposed to with all the doors closed.
Yeah,
Cool.
and it's more to, again, it's sort of a designer thing to make sure they're aware that an undercut or some form of cross flow is required. And if they've got alternatives in there, that they can use them and pass that on to the build team. Awesome.
And there is that article there. Just a couple of questions from me because we've got a few minutes left. Could you both talk about the benefits of a system that's been certified by PHI? And the second part of my question is that some of the cheaper non-certified systems in New Zealand, they're using like a flex duct to cut costs, and what are the pitfalls of using flex duct in a system?
From a passive house point of view, obviously the losses that you get out of a flexi duct, it's just not compatible. And that's why we use the semi-rigid, and obviously that has other benefits in terms of not only efficiency, it's acoustic as well, smooth core, for anti-static, for dust, etc. The passive house side of it is obviously done over in Germany where they certify the data. They look at the leakage of the actual unit, so the air that's crossing over the heat recovery core, those chambers in the unit, so that there's the cross-contamination, etc. Whereas a non-certified unit, typically it may still be an okay unit, but they downrate the percentage unless you can get a certifier to look at the data of the unit and say, yes, okay, I'll allow 80%, for example, rather than 75. And it's really just the build quality on the cheaper units with the stretchy ductwork. They definitely do drop off in the quality, and you typically get a noisier solution. So the comfort of the home, not only from an efficiency point of view, but comfort acoustically.
I think it's probably worth pointing out that if you're trying to go for something like certification, getting the most high performing unit you can makes quite a big difference. It's actually a reasonably low cost way to get energy efficiency, just by spending the extra money on a good system. If you do get a non-certified one and you have to downrate it, you're going to have to add extra insulation elsewhere to try and get your numbers to stack up. So yeah, choose a system with a really good heat recovery percentage.
Yeah.
Awesome. Thank you for that. Richard says there's a 12% penalty if a heat recovery performance reduction is mandatory if it's not Passivhaus certified. And I'll add to that, it does depend on the standard that the system has been tested to, whether that is using the same criteria as the standard that PHI uses. So that will
the Eurovent or yeah.
Yeah. So we're just about coming up to time. I will just sneak in one more question. With the ERV units, are there any circumstances that you would recommend someone choose an ERV over an HRV?
Normally to do with climate, again, I would say 99.9% of the units that we've supplied in the last 10 plus years into the New Zealand market have been heat recovery cores, not ERV. And I probably would say that in summer would be the better time to put that enthalpy core in. So it may even be something that you could switch around if you wanted to really manually do that.
And that's a Central Otago kind of thing, isn't it? Where you've got really dry continental climate,
Correct.
and people are actually struggling with the humidity being too low because the outside air is too dry.
Correct.
Yeah, yeah.
Yeah. Does that answer the question, Jess?
Yeah, no, that's perfect. Thank you. So Richard says ERV for nearer the equator normally, e.g. Northern Territory, Australia.
Correct.
Cool. Okay. Thank you both so much for your time. You've been just a fountain of knowledge, and I'm sure everyone's got a lot out of this. And if would you be willing for people to get in touch with you directly if they have any questions?
Sure.
Absolutely. Always
Awesome.
here to help.
Yeah, and yeah, thanks again to everyone who's come along, and especially to our members. With your membership really helps us to be able to deliver things like this webinar series, and we look forward to seeing you at the next one. I think this one might be the last one for the year. I'm sure Nikki will correct me if I'm wrong, but if we don't see you before Christmas, then have a great Christmas. Get that in before anyone else does. So thank you very much. Lots of compliments coming through for you guys. Well done.
Thanks for the attendance.
Guys,
Thanks, Tim.
Bye-bye.